Hello everyone, welcome back to my Chem Corner. In today's video, we are doing question number 4.15 from chemical bonding and molecular structure. So the question reads, although both CO2 and H2O are triatomic molecules, the shape of the H2O molecule is bent while the other is linear. Explain this on the basis of dipole moment. So here the question clearly says that you need to explain the shape of two molecules based on dipole moment, where one molecule is bent and the other one is linear, even though they are triatomic. What do you mean by triatomic? Triatomic molecules are those that have three atoms in it. So triatomic means three atoms. So before we go into finding the shape and the reasons behind them, we should know what is a dipole moment. Okay, so I've written it here for you to make it easier, that when two atoms in a bond have different electronegativity. So say I have an atom A and an atom B. Atom A will have one electronegativity, the other atom will have a different electronegativity. So when that happens, electrons are not shared. Why? Because the one that has more electronegativity will pull the electrons towards itself. So whatever electrons are here, the one that's belonging to A and the one belonging to B, both will move towards the more electronegative element. Now when that happens, when the electrons are going to move towards the more electronegative element, it creates a partial negative charge, and on the other one which lost its electron, it will have a partial positive charge. When you have a partial negative charge and a partial positive charge, such kind of a bond is called as a polar bond. Alright, and a polar bond explains a dipole moment. So when you look at this particular molecule, it has a particular direction in which the charge is moving, and also there is a certain distance between both these charges that are formed. So basically that is dipole moment. Dipole moment is the product of magnitude of the charge and the distance between them. Alright, so now that we know what is a dipole moment, let's see the reasons behind difference in their dipole moment. So here, carbon dioxide, carbon is the central atom, and for water it is oxygen. Now when you look at carbon dioxide, they say it is linear in shape and water is bent. What is the reason? If you look at the structure of carbon dioxide, oxygen is more electronegative than the carbon. So when that happens, your electrons are moving towards oxygen. So when electrons move towards oxygen, the direction is going to be away from carbon, and for this to happen, the bonds must be equal and they must be opposite in order to nullify each other. This one is opposite to this, and therefore they will nullify each other. Okay, so when that happens, the dipole movement is going to be 0 as the value. Alright, now when you look at bend in water, oxygen is more electronegative than hydrogen, so oxygen obviously is going to pull electrons towards itself. So when it is pulling electrons towards itself, what is happening? Here, when it is pulling, the dipole moment will have a value. The dipole moment is going to be 1.84. And for this to happen, there should be, you cannot have a 0. 0 is when it is pulled away from the central atom, but here it's going moving towards the central atom, and for that particular dipole to happen, this structure should have a bent shape. Okay, this is an important factor. So when you look at VSEPR theory and when you learn about dipole movement and octet rule and all, though yes, you learn them separately, they are actually interlinked. The topics are interlinked.